Alright, okay, so let's understand the design of a slab, and I'll be comparing the same method with ETABS. Alright, in here I got a lot of parameters for the design of slab, which is the thickness, the depth is given, the color is given, the length is given, grade. I got modulus of elasticity, Poisson ratio. I don't want to care, Poisson ratio cannot be 0, so just ignore it. And I can have dead load and live load right here. Alright, getting the bending moment of the slab. This one is the weight into length of the span of the slab is just 4 meter by 8. So the total weight that comes to be factor of safety, which is 1.5 into dead load plus live load. As you can see, self weight is not being considered right in here. We know XU by D based on IS 456.466. It's totally based on the grade of steel. I think it's, and also the depth of the compression block can be given by M, that is ME by BD square F5CK. Just same thing which is shown in the design of beam. If you want to know what and all are these property, you can get into design of beam video. So which is B, you know what is B? B is always 1 meter. Depth is the depth of the slab, and alpha, and CK is right there. And XU by D, calculating XU by D is 0.171, which is always less than XU max by D. So an area of tensile, so which means that we don't want to provide any sort of compressive reinforcement is not required here. So area of tensile steel is also given by the formula it is, and the depth is there, and area is ME by Fy gamma into Z, which comes to be 483. So let's try and plug all these variables in ETABS. In here, opening a new model here. We know the span is 4 meter and the width of the slab is 1 meter. All these things can be decreased right into 2. And we don't want to consider any story, so let it stay there. First thing, I'll be defining a sort of concrete material here, which comes to be 30 megapascal M30 with modulus of elasticity given. Okay, so let's get into here. I'm gonna make a concrete material. Sorry, India. Concrete, it's M30. Let it stay as 25, and the modulus of elasticity is 25 000. Okay, Poisson ratio is, let it be 0.2, and there's nothing other than okay, there's nothing more given. Alright, that's it for now. Then let's then I'm gonna hit OK. Then I'm gonna create HYSD. HYSD is a rebar, and come on, rebar. The grade is questionable. The grade is what? The grade is 460. Oh my god, getting to 500. And I can edit this thing. It could be like minimum yield strength is 460, minimum tensile strength, expected yield strength is 460. So let's change all the sort of things right in compression. So the tensile strength is not given, not one I consider. Let it convert right into 460. There's no other data is given here. There's only the value 460 is given. They didn't talk about any of the properties other than the grade. Let's change up the same modulus of elasticity is the same to correct. We don't want to change anything from here. That's it. Okay, so let's make a slab. Get into slab sections. I'll be modifying the slab, concrete material, and the thickness of the slab, it could be like 150, and it shall be always a shell thick slab. That's it, slab 1. Now let's draw the slab. using the draw thing. The slab 1, I can draw slab 1 and place it right here. Oh man, it's wrong placement. I'm writing story 2, get into story 1 and get into base and trying to fix it right there. After fixing up, just right clicking the slab will bring up some properties. In here, I like to add more meshing pattern right into this slab. So floor meshing type is, I like to pick up an auto cookie cut, and I like to divide meshing. I'm just only refining meshing patterns right into a single side of 250mm. And you know, I wanna add restraint. I want to turn off the restraint options right here. Why am I doing this is, normally if a slab is being considered, the perimeter of the slab, you'll be having a sort of beams here, and all the connection from the beam to slab will be attached to itself. So which means if the slab is bending, a portion which is attached to the beam will stays right in its place. As I'm drawing a one-way slab, in this case the bending will be something like this. As the corners was restrained, the corners won't bend. The bending will be always happening right into the inside. If I'm taking a cross section of it, the bending will be something like this, as here as a beam, and here we got a beam. So this portion won't be bending. In the case of one-way slab, as I haven't modeled any sort of beams, we got supports right here. Only this portion connected to supports, all these nodes connected to support will be bending. So the bending will be something like this. This is the beam and this is the beam, and the other direction is the view from this side, and the view from this side is something like this. So there is no sort of beam here, so only the 4 nodes will retain the connection. In order to convey this property to ETABS, I'll be using add restraint right into no. That's it. Now let's apply some sort of load here. Just select the asset. I can get into uniform load. I think the dead load is 5. Dead load is 4 and the live load is 5. Dead load is 4 and the live load is 5. Sorry, dead load is 4 and the live load is 5. Or that's okay. I don't want to consider the self-fade, so I like to turn off the self-fade, turn this right into 0. Okay, then let's add a design strip right into this slab. The design strip is very important, as the reinforcement will be shown right away from the design strip. So in order to draw the design strip, I like to turn off the snap option, get into draw and snap option, and I'll be picking up only the midpoints. I can find it right here, only the midpoints I'll be there. And I'll be drawing up design strips right away from here, picking up design strips. And you know, the width of the slab is 1 meter, so I'll be turning this so I'll be turning each and everything right into 500mm. Alright, okay, then pick up the first point and pick up the second point and right click for exit. Alright, okay, so just getting to view set display options. In the object, in the other assignments, I can have the width of the design strip. It's right here, so you can see that the width is entirely filled into the slab. And also, let me change some of the properties of the design strip. Right clicking the asset, I can turn it right into the HYSD bar. There's nothing else we can do. Oh, alright, that's all. Now if I try to pick up the load combinations here, I like to have the combinations. It could be like, you can see that the combination is given here. It can be like 1.5 into dead load plus live load. Okay, add a new combination in combo 1.5 into dead and 1.5 into live. That's it. Alright, okay. And I'm trying to analyze the structure. Alright, as you can see, the bending pattern looks something like this. The edges are not restrained right into the beam, which is a special case in this problem. And I want to see the bending moment. I can get into strip forces, pick up the combination here. I can have a bending moment, and I would like to show values right in here. So it could be something like 26 or 27. As you can see, this number is 27, which comes to be correct. Alright, next thing, I'll be having some sort of I'll be allowed to change this support right into roller. Just get into assign, unlock the model first, assign, and this restriction is only in the user direction. That's it. And for this, I don't want any sort of support here. Well, assign. I don't want any sort of supports here, so analyze this figure once again. So the first thing, I don't want to get into all these options. First, I'm gonna pick up the combinations, which is combo 1.5 into dead and alive. Next thing, I can get into select storage for design. As the slabs right there in the base, I could pick up the base. And finally, let me start the design. The number is 577. I got the value, which comes to be approximately same 583.03, which comes to be same as that of our manual calculator result. So I